right, now we're moving on to absolute value inequalities. So kind of putting together everything we've been doing the past few sections. So we're going to solve and graph absolute value inequalities, then write the solutions in interval notation form. All right, now, whoops, did not mean to do that, sorry. So absolute value inequalities work the same way as regular inequalities. You'll need to set up two problems, very key. Now, when you set up the second problem, make sure to switch the inequality symbol around, right? Because if you think about it, we always flip the symbol when we multiply or divide by negative. Well, what happens here? We go from 5 to -5. So therefore, when we write that one, we flip the symbol, okay? Now, when you have a less than problem like so, okay, we're going to use the word and it's going to look like this, okay? If it was less than or equal, it would be solid dots. If it's a greater than symbol, all right, we're going to use or, and it's going to look like this, going in opposite directions, all right? So, just like before, get the absolute value by itself. So right now, we want this to be by itself, but there's a 2 in front of it by multiplication and a -4. So again, it's similar to this concept. All right, where we'd add 4 and then divide by 2. We're going to do the same thing here. The only difference is, 1, it's an inequality, and 2, we have an absolute value. So after we get this alone, which is really this, we're going to have a little bit more work to do. All right, so first thing we do is add 4. That's going to give us 2, absolute value x minus 3 greater than 16. Then we divide by 2. All right, that cancels, leaving me the absolute value of x minus 3 greater than 16 divided by 2 is 8. Now at this point, we finally have the absolute value alone, and now we're going to bust it up into two problems. X minus 3 greater than 8, and x minus 3 less than -8. And now we're just going to add 3 to both sides. So x, 8 plus 3 is 11, so x is greater than 11. And if we add 3 to this side, we're going to get x is less than -8 plus 3 is -5. All right. Oops, sorry about that. So remember, with a greater than, we're going in opposite directions. So I'm going to just put my -5 right here and my 11 here. That's a 10, not 11. Numbers are hard. So there's my 11. So greater than 11 means open dot towards positive infinity, and -5 less than -5 open dot towards negative infinity. Okay? Now remember, that's what we said here. Looks like this, and it's going to be an or statement. So when we do our interval notation, we're going to say, I'm just going to put or right now. Okay? And we have my two possibilities. This one's going out towards positive infinity. This one is going towards negative infinity. And then we just put the numbers in, -5 and 11. So it's either -5 to negative infinity or 11 greater than 11 to positive infinity. It doesn't include the -5 or 11 because we have open dots. All right, we have a decimal. Doesn't matter, no big deal. Notice it is already by itself, and it's a less than, which means it's going to be one of those in-between graphs. Okay? So I'm ready to go. I can bust this up into two problems. X plus 3.5 is less than or equal to 15.7. Let's go over here more. And x plus 3.5. Remember, I'm making it negative 15.7. Therefore, I flip this symbol. And now I'm going to subtract 3.5. So x is less than or equal to, that's going to be 0.2. 15 minus 3 is 12. 12.2. And here, when I subtract 3.5, I'm getting more in debt because I owe $15.70. I'm going to borrow another $3.50. So x is going to be greater than or equal to negative, that's going to be a 12, 15, 3 is 18. That's going to be 19.2. All right. So now my graph, I'm going to put negative 19.2 here. I'm going to put 12.2 here. All right. And then solid dots, and it's in between. And this is simply, bracket, because it is a solid dot, negative 19.2 to 12.2. Brackets on both ends because it is greater than or equal, less than or equal. All right, so here we have a special situation. Remember when we did equations, and if this was, it said equal to -2, we would immediately say no solution, all right? But we don't have that right now. We have an inequality. So there's actually two situations, so I'm just going to write this. Please add this to your notes. X plus 8 greater than or equal to -2. Now, we're not going to have to solve either one of these. These are special situations, all right? Now, if you think about this, this is always going to be a positive number, right? The absolute value of anything is going to be positive. So what we have here is we're saying that A or 0, because if I put -8 in there, I'd have 0. But let's just go with positive because it's kind of more obvious. I'm here saying that a positive number is less than or equal to a negative number. Well, that's a false statement, right? And so therefore, there is no solution. Or we could put that, or we could put that. Those are three ways to say no solution, all right? And if you look over here to the right, this, again, we're basically saying is always going to be a positive number or 0, all right? But here we're saying that a positive number is greater than or equal to a negative number. Well, that's a true statement, all right? And that would be infinite or all real numbers, okay? So those are two special situations. Just want you to be aware of them. All right, this one, a little bit more work. Again, we have to get this by itself. So the first thing we're going to do is get rid of the 1 by addition. So we're going to keep this big old mess in the absolute value bars, all of it. Greater than 3 plus 1 is 4. Now, we're ready to go. The absolute value is by itself, but we have a little bit of work to do because there's a lot going on here. So we have x minus 2 divided by 3 is greater than 4. We write it all again. X minus 2 divided by 3. Remember, we make it -4, and therefore we make this less than. We flip the symbol. Now we have all the work to do. So we need to multiply both sides by 3. Okay, that cancels, leaving me x minus 2 is greater than 4 times 3 is 12. Then I'm going to add 2. X is greater than 14. Over here, again, I'm going to do the same thing, multiply by 3. And that's going to give me x minus 2, this time less than -12. Now when I add 2, I'm going to get x is less than -10. So I put my two numbers on the number line, -10, 14. X is greater than 14. X is less than -10. So therefore, again, we're going to have two parentheses. All right, negative infinity, positive infinity, and then our two numbers, 14 and -10. And that's it.